A very good morning to Prof. Maya Dr. Muhammad Sani Sajadi. We are from Group Mathematics Computer Graphics, and today we would like to present our group assignment 1 about the finding journals of human gait analysis. So before we step into our introduction about the human gait analysis, I would like to introduce my team members. So for the first one is Chan Xuejing, second is Hao Yimei, and last but not least is me, Ng Chunxuan. Next, we'll move on to our introduction about the human gait analysis. Human gait analysis is playing a vital role nowadays. To ensure the human health standard is increasing by years, the human gait analysis is implement and getting data from 51 healthy participants with a motion capture, initial measurement units, and computer visions. Next, human gait analysis is important for understanding the biomechanics, diagnosing locomotor disorder, and optimizing the rehabilitation protocols. Regardless of the advancement in motion capture and wearable device, there remain a limited availability of the open sources, high quality dataset of details about gait analysis. So this research is to address this gap by presenting a comprehensive dataset collected from 51 healthy participants with a motion capture, initial measurement units, and computer vision skill. Next, we'll move on to our problem statement about the human gait analysis. For the first problem statement is development in biomechanics and machine learning application have been restricted by the lack of large freely accessible gait analysis dataset. So without this dataset, the developer and researcher is hard to get the data set about the human gait analysis. And second, no substance has been established about how efficiently the portable modalities such as the IMU and video-based posture estimation perform in a comparison to motion capture system of laboratory system. So this study is aimed to provide a gait analysis dataset that facilitates such comparative study and contribute to the development of portable and accessible biomechanic assessment tool. Next, we'll move on to our research objective. So in our finding journals about the human gait analysis, we will find out there are three research objectives. So for the first one is to collect and provide the gait analysis dataset from 51 healthy participants. And second is to integrate the motion capture IMU data and video-based human pose estimation into a single dataset. And last but not least is to enable the comparative study between the standard laboratory, great motion capture, and portable modalities.
Hi, I'm Chan. I'm going to talk about the literature review. So there's a lack of 3D datasets in gait analysis. And gait data is important because the most primary form of locomotion of human is walking. And the walking pattern is usually related to various of kind of disease. The measuring apparatus to get the datasets are usually very expensive and limited. Also, meantime, a standard procedures and techniques are highly required to ensure a high quality datasets are recorded. Data are collected from musculoskeletal analysis to estimate the joint loads with different gait speed. Last, the datasets of the gait is analyzed accordingly to biomechanical characteristic respectively. Next will be the methodology. So the data collected is in the Humio Motion Laboratory in University of Eastern Finland, and the data capture is the 3D marker trajectories and the ground reaction force and moment. So also using the portable modalities like the inertial measurement units (IMUS), and the dataset is handled by the MATLAB and the JSON. So next we will proceed to the steps of the data capturing. So first, the lower parts of the body of the participant is marked and the IMU device is placed accordingly to the biomechanical procedures. Then next, the data is collected through 10 infrared optical motion captures and the IMU device to record the accelerations and a video camera to record the 2D key point frame by frame. So the participant is required to perform a 60 trial walks with different speeds like slow, comfortable, and fast. And lastly, all the motion data, force plate marker, and video data is synchronized using MATLAB. Thank you.
And how you may proceed with result and discussions. From the dataset overview, the Kuopio guide and the dataset provides a set of data to analyze and compare motion capture mocap systems with portable modalities like inertial measurement units, IMUs, and video-based key point detections open pose. The dataset's diverse components are 3D mocap trajectories, force plate data, IMU recordings, and open post detected 2D key points, which offer a robust resource for validating with the feasibility and accuracy of portable motions analysis tools compared to the laboratory-based standard. Next, for your information overview, the datasets comprise 51 participants with a range of demographic and anthropometric attributes. The average age is around 30 years with a balanced representations of young adults. The anthropometry is a detailed measurements including inter-axis distance and joint-specific weights, valuable for biomechanical modeling and personalized analysis. The dominance of the right leg is among participants with 49 out of 51 highlights potential bias with when generalizing findings to left leg dominant individuals. Our research findings are 6 unique configurations combining speed and sagittal visibility were implemented with 60 trials per participants. Open post successfully extracted 2D key points from video, but limitations in differentiating the participants from background elements cause occasional artifacts. IMUs provide continuous kinematic data using proprietary fusion algorithms, but synchronizations with the analog signal was crucial to maintain temporal alignment. However, there are limitations from the studies. Some trials contain errors, misforced placed plate steps, and external influences, operator presence in video which introduce the noise. At last, our research findings we conclude that the Copio GAIT dataset provides valuable multimodal data for advancing GAIT analysis, featuring synchronized recordings from optical motion capture systems, portable inertial measurement units IMUs, and video-based human pose estimations using open pose. However, some video frames can result in inaccuracies in human pose estimations, and some trials include incorrect ground reaction force data due to participants fail to step on middle force plate. Last but not least, these are the references that we use to conduct the research, and that's all from us. Thank you.